look at 3.6, last section before our second test. Polynomial. I promised something and I did not deliver. So I would like us to look at a couple of examples. Did we look at these examples, rational functions? Because I keep saying that these are way more sophisticated applications. I thought we did, but maybe, did we?
Yeah.
Okay, good. So we looked at those two applications in which, again, this is not just simply a trajectory, a quadratic trajectory, but we looked at applications in which these sophisticated functions were used, right? When we swallowed a piece of sugar and what happened to the pH level in the mouth. It cannot be modeled by a quadratic function or polynomial or any simple function. That's why those complicated functions were developed. And the other one with a medicine, right? A patient is injected with a certain medication, and the concentration of that medication in milligrams per liter 5 hours, 2 hours, or 10 minutes later. So that is another sophisticated situation. Okay, so the last thing is polynomial and rational. Inequalities. Again, these are not difficult, but they're not simple situations like linear, absolute value, or compound that we looked at before in chapter 1. Okay, so let's take a look at x, negative x minus 2, x minus 3, and 2x minus 6. I'm going to put 2x minus 16. Let's say you want it less than or equal to 0 or greater than or equal to 0. It doesn't matter. We just want to make one up. Perfect. Okay, what type of inequality is this? Obviously, it's an inequality. But what type of inequality is it? We're talking about polynomial or rational. Obviously, it's not rational. It doesn't have a ratio. So it must be polynomial. How many factors do I see? 1, 2, 3, 4. 4 factors. What is the degree then of this polynomial? 4, of course. 4 factors, 4, yes, because it's x times x times x times x. Copy the base, add the exponents. Degree 4. Agreed? Okay, perfect. So it's a polynomial inequality, degree 4. I'm going to create a table in which x at the top is the variable in the problem. The next row is the first factor in the problem, which happens to be x. The next one is negative x minus 2, which is the next factor, and then x minus 3, and then 2x minus 16. And then the last one, what do you think the last row will be? The whole thing. The whole thing. Since, of course, you know me, I ran out of room, I'm going to call this a product. And I'm going to say product. If you have room, just put the whole thing. X times this times this times this. I never have room, as you know already. Okay. I'm coming back to our product, which is the polynomial inequality. And can you please tell me when is this quantity 0? For what x?
0.
Of course. When is this quantity 0? For what x? Negative 2. Do you all agree with negative 2? Negative 2 with minus in front will be 2. 2 minus 2 will be 0. What about this one? This will be 0 when x is awesome. And then this one will be 0 when x is perfect. I need these numbers in ascending order. And I will put them in the first at the top of the table. So, from left to right, what will I put in? Which one? Which one goes in first? Negative 2. Then, perfect. Then, very good. And then, that's it. Now I would like to put a 0 in each row where it belongs. Where do I write the 0 for x? Under which number?
0.
Under 0, of course. Where will I write a 0 for negative x minus 2? Under negative 2, of course. Thank you. Where will I write the 0 corresponding for 2x minus 3? Is that clear? Yes? Perfect. And where will I write the 0 for 2x minus 16? Of course. Thank you very much. Now, the next step is, what will happen when x is negative 2 to the entire product, when x is 0 to the entire product, when x is 3 to the entire product, and when x is 8 to the entire product? In other words, I'm saying, if any of these factors is 0, what will be the result of the whole thing? In other words, how much is 0 times 5 times 10 times 12?
0.
How much is 5 times 0 times 5 times 9?
0.
How much is 5 times 10 times 0 times... You got the picture, right? So what happens when any of those factors is 0 then? Correct. The product will be 0. Perfect. Now, one more question. You realize that we wrote everything in descending order. This is crucial to remember. Everything in descending order, correct? Perfect. How many of these, they're all linear factors, right? Linear. So how many of these have a positive slope and look like this if I were to graph them? How many? 3. This, and this will all look like this. We agree? Meaning they come from which values? And they go to? Good. I'm writing exactly what you told me to write. All of them are below the x-axis before they cross the x-axis. And then all of them are positive because they are above the x-axis after they cross the x-axis. We agree? Perfect. Now, can anyone explain what happens to the second factor? It can no longer look like this. We agree? Because it doesn't have a positive slope. It will look like this. So the sequence of signs will be different. What will that be? From
Positive infinity to negative.
good. I'm just writing exactly what you told me. Remember, this is the product, so we are multiplying everything. So on the first subinterval, the first factor is negative, the second is positive, the third is negative, the fourth is negative. 1, 2, 3 negatives. When I multiply or divide them, it doesn't matter. What sign do I get? How many? 3 negatives. How many? How much do what do I get? Perfect. On the next subinterval, I have 4 negatives. What will be the sign of the product? Very good. On the next subinterval, I count 3 negatives. What will be the sign of the product? Perfect. On the next subinterval, I count, as you notice, I don't even look at positives. They don't mean anything. So on the next subinterval, I see 2 negatives. And on the last one, I see 1 negative. Perfect. Stay with me. Because now it's the moment of truth. Now is the choice that we have to make. This will tell us what to pick. I want all this product to be greater than or equal to 0. Which sign will I look for that is greater than or equal to 0? Positive. So I'm looking now at the product. I don't care about anything else, but just this row now. Where is the product 0? Here and here. But the question is, for which x values? Which x values will make the product positive? These x values. Which x values will make the product negative? These x values. So I want this, and I want this. And that is the solution. X in the interval. What does this mean? If I pick x between these two, it's guaranteed that this product will have what sign? Correct. If I pick anywhere else, it's guaranteed that this product will have what sign? That's it. Now you can say, I don't like to think in terms of end behavior. Okay, fine. Then all you have to do is pick a number between these two, between negative infinity and it's 0. I pick -5. Okay, it's negative. I pick a number between it's 0 and infinity, 10. So it's positive. For the next one, I pick a number between negative infinity and it's 0, -10. -10 with minus is 10, minus 2 is 8. I pick a number to the other side, 10. -10 minus 2 is negative. That's another option. Since we know end behavior, and we know the slope, and we know the leading coefficient, I think it's easier to think in the terms of positive slope or negative slope, but there is another way, by simply picking a number. Ready? Okay, let's look at an example with a rational. Identical situation, just a minor difference. Let's say -x plus 1 times x minus 3, everything divided by x plus 6. Since the first one was greater than, let's make this one less than. What type of inequality is this? It's not linear, it's not quadratic, right? It's not polynomial. It's not absolute value, it's rational. I know you already said it, but I just want to review all the other ones that we know. Okay. How many factors? Now, if it's not factored, we have to factor it. So we can look at an example like that. How many factors we see? Good. So x is the variable in the problem. -x plus 1 is the first factor. X minus 3 is the next. And x plus 6 is the last one. And now I have some room here. I can put the whole thing. Instead, if you don't want to write all this, just put ratio or whatever you want to call your left-hand side. That's fine. So let's put the numbers, the key numbers on the side so we don't mess them up. So the first one is 0 when x is? Very good, 1. The next one, x minus 3 is 0 when x is? Good. And the last one? Good. So now we know the numbers. Let's put them in ascending order from left to right. First one goes in the table is? Perfect. The next one is? The next one is? Very good. Now we have to find the corresponding zeros for each row. For the first row, under under 1. For the second row, under. And for the last row? Good. So now let's identify carefully what happens with that ratio. When x is -6, what happens to the ratio? Thank you very much. The denominator is 0, so the expression is undefined. Awesome. Thank you, Nate. Okay, at 1. Perfect. The numerator is 0, a fraction is 0. Awesome. And under 3, what do I write? The numerator is 0, the fraction is 0. Awesome. So now the sequence of signs. What sequence of signs will I write for negative x plus 1? Plug in a number. You don't have to remember in terms of end behavior if you don't want to. But you have to plug in a number to the left of 1. Right. It's a negative leading coefficient. It has to look like this. Mandatory. Plug in a number. For x minus 3. You have to plug in a number between negative infinity and it's 0. It's like this. It's a linear function with a positive slope. It has to come from negative values. Any number you pick to the left of 3, 1. 1 minus 3 is negative. What about x plus 6? Very good, of course. Same idea. Leading coefficient is positive. It has to look like this, no matter what. Okay, on the first subinterval, we multiply or divide two negative numbers. Sign. Very good. On the next subinterval, I only count one negative.
So negative.
Perfect. In the next subinterval, I count two negatives. Good. And in the last one, I count one negative. Now, only now I look here. I had no reason to look there before I found the behavior of the product, the quotient. Which sign do I pick now? It says find x so that this product is less than or equal to 0. Yes. So is it negative? Yes. Here and here. But what I'm interested in is this and this. That's where the solution is. That's where x is. So then x in which interval? It has to be with parentheses because this is undefined. There is no way I can include negative 6. Union. That's it. Okay, so now we can start looking at this handout. We'll start with anything you want. We can start with this because we just looked at it, if that's what you want. It's the last problem, since this is fresh in our minds, I think. Yeah, we're doing the last one just because this is what we've been doing in the last few minutes. I'm sorry? Sorry about that. So then we have x plus 7, x minus 9 over x plus 5 less than or equal to 0. Let's work on this for 1 minute, and then we'll do it together. 1 minute. How many factors? Should I wait? And the numbers have to be established before you put them in the table. Make sure that they are in ascending order, otherwise we mess up the solution. So from left to right, you will write perfect, perfect, good, awesome. So for x plus 7, you will write a 0 where? Perfect. And for minus 9, and then here. Perfect. So then what happens under negative 7, under negative 5, and what happens under 9? Under negative 7. Awesome. The numerator is 0. Great. Under negative 5. Very good, because the denominator is 0. Good. And under 9? Yes, because the numerator is 0. Awesome. Since all linear factors have a positive slope. Yes?
How do you know if the numerator is 0?
Okay. That's okay. No. So negative 7 plus 7 makes the numerator 0.
Okay.
9 minus 9 makes the numerator 0. But negative 5 plus 5 makes the denominator 0.
Okay. Thank you.
Sure. So since they are all linear functions with a positive slope, you can plug in numbers. But since we know end behavior, it must be this. It must increase from left to right. So if you want to quickly solve this, then you will understand, you'll remember the end behavior. It's okay if you need more time. If you want to plug in numbers, that's fine. Nothing wrong with it. So on the first subinterval, if we but remember, the table doesn't work unless this is a product or a ratio. You cannot put in the table x squared plus 4. There is no need because it's always positive. So let's say negative 4. You have to factor it first. Okay? So all these examples, remember, they all have either a product or a ratio. And 0 on the other side. Because we compare signs, we don't compare quantities. Okay, so on the first subinterval, I'm multiplying 3 negatives. Or dividing, it doesn't matter. If I multiply or divide 3 negatives, it's still the same sign. On the next one, 2 negatives. Perfect. On the next one, 1 negative, and then finally, good. Only now I look, what do they want? They want us to find less than or equal to. So when is the ratio a negative number? It's a negative number here and here, which means I have to choose this and this. And that will be the final answer. So x is in the interval. I can close because the function is allowed. I have the equal symbol in the inequality. So I can put the bracket in. Union. Yes. But now I have to be careful. I cannot include negative 5. So it has to be a parenthesis. But I have to include 9 because of the equal symbol in the inequality. Perfect. Is this clear, everyone? Okay. So now let's go back and do whatever you want me to do. Whatever you would like to work on. If you want to start from the beginning, we can start from the beginning. Sure, very good. Okay, so here is the first one. We have f of x, which is 3 divided by x squared minus 2x minus 120. The problem is asking us to find the domain. So find the domain of this function. First question I ask myself is, what type of function is this? And do I have to write restrictions, or it's polynomial and it's defined everywhere and I don't have to worry about anything? What type of function is it? It is rational. That's not a friendly function. Most of the time it's not, meaning it has restrictions. It does not exist for any x value. So one option would be to factor a denominator. If factoring takes more than 30 seconds, forget it. Use the quadratic formula. Doesn't matter. So can we factor this? Okay, if we can, then how do we factor it?
It's x minus 12 and then x plus 10.
Perfect. The product is negative 120 and the sum is negative 2. Very good. So then we know that x cannot be two different x values. And those values are? Very good. Indeed. But the problem is really asking us to find what x can be. Of course, I have to find what x cannot be first, and then I'll have to conclude the domain of function f is, and it's asking us to present it in interval notation. So the domain of this function is negative infinity to negative 10 union, comma, very good, union 12 to infinity. This is a different way of saying everything but negative 10 and 12. Now the next problem is asking us to find the domain as well. But this is more sophisticated. Because it's a ratio of two different functions, you cannot say that this is a rational function. A rational function by definition is the ratio of two polynomials. The top is not a polynomial. So you can say this is a combination of a ratio of a rational function with a radical, and I will have to say yes, it is. So I'm asked to find the domain of this function, and I see two potential problems here. So one potential problem is that the denominator could be 0, and that has to be excluded. So one condition must be x minus 8 cannot be 0. Now the second condition guarantees the existence of the square root, because the square root is not a friendly function in the sense that it's not defined everywhere. So what do I have to write?
This is like saying we want x to be, to make it like.
Yes, I have to write a condition.
So x can equal 30?
I have to state a restriction for this. What can this quantity be? What type of number?
Has to be positive.
Or positive, or I can take the square root from 0. I have to include that. That's a possibility.
So what then?
So I have to write x minus 5 greater than or equal to 0. This is true for any square root. The square root of any quantity, the quantity must be greater than or equal to 0. I'm not sure why. Very, very few of my students remember this. Very few. I'm not sure what to do. So it's the square root. It doesn't exist unless this quantity is positive or 0. Good. Okay, perfect. So then two conditions. The first one means x not equal 8, and the second one is x greater than or equal to 5. We do not have to graph. I'm not asking you to graph, but I will graph it to explain what's happening here. So the first one says not 8. So this is 8, not 8. The second one says anything to the right of 5. 5 to infinity. So then, what is the domain of function g? Yes? Yes? Very good. Awesome. Union. Very good. This is it. So we made sure that the radical exists. We stated that x minus 5 has to be greater than or equal to 0. We made sure that there is no division by 0 by writing x minus 8 does not equal 0. We have to find the common territory. We had to find where both conditions were fulfilled. And they are all both fulfilled here except at 8. Good, well done. So f of x equals x minus 5 and g of x equals 3x squared minus 5. We're asked to find f comma g, g comma f, and evaluate both at 0. Ready? So let's find f comma g. F comma g. It is wise to write the definition first. F of g of x. And write f of 3x squared minus 5. Now stop and let's look. What does f say? F says this. What do I write? Okay. Good. You can put parentheses, it's not wrong, but there is no need. So this is 3x squared minus 10. We're also asked to find f comma g of 0. What will the answer be? No. F comma g of 0. Because we have the function. Let's do negative 10. Perfect. Now let's find g comma f. You're way ahead of me. That's good. Awesome. G of f of x. So this is g of, perfect. Now let's stop for a moment and see what g is asking us to do. G says this. This is what g wants. 3 times whatever squared minus 5. So what do I write? Yes. 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 Awesome. Now, I don't think we had one meeting in which this didn't come up squared. I don't think so. And this was the first thing we did this semester. I know I tortured you with this then, but it pops up all the time. Okay, so when I square x minus 5, how many terms do I get? Thank you very much. Thank you. And they are. Awesome. Now only now I can distribute 3. 3x squared minus 30x. This is plus 75 minus 5 is plus 70. Since we are here, let's find g comma f of 0 as well. Very good. Awesome. Okay. Any questions? Okay, next problem. We are given age of x, which is the 6th root of x to the 7th minus 4. And they want us to find an inner function. You can call it the way you like, and an outer. You can call it the way you like. As long as you identify the inner and the outer for me, I'm fine. What is the inner?
6 is 4 or 6.
The first function that we will evaluate if x is 15. Which function I will evaluate first for sure? X to the 7th minus 7. X to the 7th minus 4. I get one number here. Excuse me. Which function I apply to this number?
The 6 through x.
Good. I just wanted to identify because the notation is not important. You can denote this by F, this by G, I don't care. As long as you specify the inner and the outer, it's fine. Now, if you want to specify the notation, one more time. So the inner function, if you write, because they're asking us to write F comma G, G is the first one we apply and G is the inner. So G will be x to the 7th minus 4. And when we are done with this, we apply the outer, which is the 6th root of x. In my case, I don't really care about the notation. I just say I just want the inner and the outer. It's up to you. Okay, we're given f of x, which is 7x minus 1. They want us to find the inverse. They want us to graph both on the same coordinate system. But now I'm going to ask you, is this function one-to-one? Because if it's not one-to-one, it doesn't have an inverse. It is one-to-one because it's a line, and by the horizontal line test, it is one-to-one, which means it will have an inverse function. Good, very good. So, bless you. So there is a 4-step procedure for finding F inverse. The first step. I replace. Yes, because F and Y are the same. I replace F of X by Y. In step 2, what do I do in step 2? Yes, swap them. I'm allowed to do it in this case because I know that the y value of f of x will become the x coordinate or the x value for f inverse. Perfect, awesome. So now in step 3, what do I do? I solve for y. So I add 1 and divide by 7. So y equals x plus 1 divided by 7. And step 4, I use the notation F inverse for this. So I move 1 and divide by 7. No problem. So then F inverse is x plus 1 over 7. They're also asking us to find the domain and range for both. Well, they're both lines. So what will you say about the domain of F?
Real numbers.
Very good. What will you say about the range of F? Very good. What will you say about the domain of F inverse? Yes, because this is 1 over 7x plus 1 over 7. It's still a linear function. So remember, it's a rational only if it has x in the denominator. If it does not have x in the denominator and it does have a denominator, it cannot be rational. And the range of F inverse, since it's a line, it's still the same. Okay, perfect. Now they're asking us to graph both on the same coordinate system. I'm going to start by graphing y equals 7x minus 1. That's function f. When x is 0, I'll determine y. And then when y is 0, I will determine x. Okay, let's try with when x is 0. How much is y? Very good. So the ordered pair is 0, negative 1. Now, when y is 0, I have 0 equals 7x minus 1. I move 1. 1 equals 7x, so x equals 1 over 7. And you can say, really? And you're going to be able to plot this, and I will say, no, but I will fake it. How can I plot 1 over 7? Yes, I will come up with something, and I'm hoping you will agree. Okay, so let's graph. 0, comma, -1 is here. And 1/7, I'm going to say it's here. It's not, of course. I don't know how to plot 1 over 7, but I'm going to say this is 1 over 7. So this is f of x equals 7x minus 1. You can say, okay, why don't you find another nice point using the slope? Yes, I could do that. There is no point. Why? These are the most important points. The x and y intercepts are the most important ones. And I don't really care for having a perfect graph. I just care about the concept. Okay. So whenever I graph the function and its inverse on the same coordinate system, before I graph one or the other, I have to graph something. Anyone remembers what I need to graph? Y equals x. Very good. Awesome. Thank you. So we have to graph y equals x, which is the line. It's the first function that we looked at in chapter 2, section 2.5. Why is this so important? Because if you remember, this point where any of the two, in this case the function crosses y equals x, the inverse must cross as well. Because this point is like 1, 1, 2, 2, 3, 3, 4, 4. So if I reverse the order, it's still the same point. So now without calculations, can anyone give us two ordered pairs that will help us graph the inverse function?
1, 0.
Careful. Yes. -1, 0, right? So if the function has the ordered pair 0, -1, the inverse function will have -1, 0. That's the purpose of the inverse function, right? So it's completely symmetric on the other side, -1, 0. And of course, completely symmetric on the other side, and don't hold me responsible for 1/7, please. And this is the graph. So this is f inverse of x, x plus 1 divided by 7. The graph is not perfect. As you see, I have a little bit narrower portion here than here. The graph should be absolutely perfect, and they should overlap. My graph is far from being perfect, as you see. You have to, yes.
Okay.
Thank you. Okay, next problem. Any questions on this? Okay. In number 6, we are asked to find f inverse of g of 8. We're not given f. We're not given g. We can't calculate f inverse because we don't know how, because we don't have the function. But we're given two tables. So where is the starting point? I need to find f inverse of g of 8. So what do I have to find first? What is it? Of course, g of 8. We don't have x. So I have to find g of 8. Can I find g of 8? How much is g of 8? Very good. So then the problem reduces to, or comes up to be, just f inverse of -6. But I don't have a table. I don't have a table for f inverse. So let's discuss this. This is based on just the very previous example that we looked at. There must be a number that the function is applied to and returns -6. Because now all we care about is to find f inverse of -6. So if there is a point 10 -6 in the table, then f of -6 will be 10. If there is 1500 -6, then f inverse of -6 will be 1500. So now all I have to do is look. That's it. That's the answer. It must be 7. Because f of 7 is -6, obviously the point is 7 -6, and the reversed point must belong to f inverse. So this is 7. Very good. Awesome. Yes?
I just wanted to write the distance too.
No, it's good enough if you write whatever explanation you want to present. That's fine by me. Okay, so then we are given two ordered pairs, -4, comma -4, and 5, comma -3. We're asked to find the distance.